All right, here for video segment one for week one. We're going to review and look at chapter 7 again, go over some of the momentum stuff that we did. So if you look at objectives, kind of narrowed those down a little bit because I know it's review and because online, everything's just a little bit different. So objectives we're going to look at, make sure we can define what momentum and impulse are. We want to be able to calculate, but look at the formulas for finding momentum and impulse. And then looking at the law of conservation of momentum and what are some examples that we used for conservation. Also, what kind of examples did we use for momentum and impulse? Well, as we go through, momentum basically is mass in motion. When you look at it, it's the mass multiplied by the velocity. And momentum, at least scientifically speaking, definitely there has to be movement taking place. I know a lot of times in popular culture we talk about, the momentum has changed. That's just the feeling of stuff. But in science, it's actually defined as a quantitative thing where it's a mass times a velocity. If an object is not moving, it'll have no momentum. So when we do it, momentum technically is a vector quantity too. It does matter with velocity because it does depend on a direction. Most of the time in the problems that you guys do as practice and stuff, as it says there, the direction is not an important factor of what you're doing. So it's just basically mass times speed. And one of the things this book does a lot is it tends to kind of interchange speed and velocity, even though technically they are different. So one of the major things we talk about is momentum is something that your mass is important. It's one of the things we look at, but it's something that's small, that's moving really fast, can have just as much more momentum than something that is very large. So we look on that example that roller skate can end up having more momentum if it was moving faster. And the product of the mass times the velocity was more than the truck, the big massive truck that's moving much more slower. So momentum is something that we take into account both of those things. And when we look at impulse is closely related because it's the change in momentum. It's how much your momentum has changed. And we can find that by something that's a little bit different. It's force in time. Because it depends. The change in momentum is something that's going to occur over a change in time because momentum has a speed. So you can either slow down over a greater period of time, you can speed up over a greater period of time, and that's going to then change your momentum, and then which is going to be your impulse. So when we're finding impulse, it ends up being the amount of force you have times the time. And I know when we were doing these types of problems back a month ago or a month and a half ago, when we were looking at it, one of the things we had trouble with is that really the question may be asking for a momentum or a change in momentum. And so the first thing you guys thought of was let's do mass times velocity because that's what momentum is. But technically, impulse and momentum are equal to each other. So we say the change in momentum is equal to the impulse. So as you see in the last equation up over here, you have force times time that is equal to a mass times velocity. So it really comes down to what are they talking about in the problem? Are you given masses and velocities? Well, then you can figure out a change in momentum, which is your impulse. Or are they giving you force and times, which then you can figure impulse, which could be also your momentum. Well, a couple of different things you talk about what changes momentum. You can increase the momentum. And like I said, we're going to try and give some examples of this stuff. And basically, with some of the examples we gave with increasing your change in momentum would be things like that you would want to follow through. If you're hitting a baseball, as you swing, if you just stop on the impact, the ball is not going to go as far. You're not going to have a bigger change in momentum unless you follow through. Talked about hitting a golf ball the same way. A lot of those things, like I said, are sports related when you talk about momentum. And how that if you follow through with your swing, you're having that force that you're exerting over a greater amount of time. And if you take that same force and multiply it by time, you have a greater change in momentum. Well, the ball's masses aren't going to change, whether that be the baseball or the golf ball. So what's going to change is the speed or the velocity at which it's